Hi, everybody. So this is our first lecture, Chapter E, which is for essentials. We're going to talk about common units, how we measure things, which is going to be super important in that first lab, and then problem solving, right? So there are qualitative and quantitative measurements, and those qualitative ones are where we describe, changes in color or physical states, but we're not taking numbers. A quantitative is that number measurement, and it will have varying precision and accuracy, which we'll talk about in a few slides. And the nature of the measurement is either qualitative or quantitative. In a lot of y'all's labs, because we don't have scales to use at home, or we're assuming you don't, they're going to be more qualitative. But in a normal lab situation, we're very quantitative in our labs. So just remember that measurements have two parts. They have scalar or a dimensional unit. So we're talking about units specifically. We will use these SI units, which are going to be on another slide, and you're going to need to know some of them. And then there's always that numerical value, and that precision, or how precise it is going to vary on the instrument. And then there are different types of error, but we're not going to cover error since y'all won't have that in lab, really. Okay, so these red ones are the SI units you need to know. Okay, they will be on tests, they'll be on quizzes, they just may appear. So the SI unit for length is going to be meters. Mass will be kilograms. That is the only one that has a prefix. The mass unit is not grams, but kilograms. We, in chemistry, do normally use a whole lot of grams just because we're working with smaller substances, but the standard unit is kilograms. Also for time, it's seconds, not minutes, so those kind of confuse some people occasionally. And then our temperature unit is, of course, not Fahrenheit, because Fahrenheit is not the scientific one, but it's a new one, which is Kelvin. And we'll talk about that more as the semester progresses. There'll also be a little bit in this chapter E. And then moles, of course, if you took chemistry before, you know about moles, but moles are like the basis of chemistry. Okay, so those five you must know. They'll appear on quizzes. Current, amps, that's going to appear in Chem 2. And then luminous intensity, candela is normally more of a physics unit. And I am sorry, my dogs are being a little crazy right now. So if you hear some background noise, that's what it is. All right, as for prefixes, you will need to know some of these, and you're going to be using them a lot. So I do suggest you memorize them. Now, I understand you're at this home situation, so do you have to memorize them? No, but we are going to use them so many times that you're going to memorize them. So the ones that you're going to need are kilo, centi, milli, and then nano will appear, but only in chapter 2. All right, so it'll be on the first test, and then it'll be on the final, but kilo, milli, and centi, we use those throughout the semester. I do want you to take note that maybe on Mastering Chemistry, you'll see some of these other units, but you can always come back and refer to this slide. All right, and here's this temperature scale. So remember I told you we do not use Fahrenheit in science. We use Celsius normally, and that's because Fahrenheit's not a concrete scale like Celsius and Kelvin are. The reason Kelvin is the standard unit, or that SI unit, is because of this absolute zero value. Oh, sorry. This absolute zero value. There is no number in temperature that goes below that absolute zero value. It does go up infinitely, but absolute zero is where everything stops moving, like all particles at their very, very smallest level. That's where we assume they stop moving. So that's why we use Kelvin. Also notice the Kelvin and Celsius scales are directly related. They're just shifted by 273 degrees. So on that note, this is the equation. We will use this equation now. We will also use this equation later in chapters 9 and 10. So just make sure you're okay with it. Kelvin is equal to Celsius plus 273. I do believe there are some Fahrenheit questions and Celsius questions that appear on Mastering Chemistry. Just use this equation here. You will not need to use it on a quiz or test, though. Okay. So precision and accuracy are super important, and especially in lab situations. But precision is the agreement or the closeness of a series of measured values. So we normally do multiple trials in science when we're in lab, and the closeness of them to each other is how precise they are. This is kind of like on a bullseye, and I believe there's a picture in a minute. But even if you're not shooting the center of the bullseye, if they're all in one area, that would be precise. Okay. Accuracy, on the other hand, is that it's close to the actual value. And so this is like for grades, you get 100 and so you were very accurate. Or you have a 95, you're very accurate. For the bullseye scenario, it would be that you're at the center of the bullseye. Precision with grades would be like you're a B student, you've gotten B's on all your tests, so your tests have very precise grades, you're consistent. Precision is more like consistency. Okay, and then there's always going to be some uncertainty. There's always this uncertain digit, but we're going to talk about that when we talk about SigFigs. And you'll be using a ruler, I hope. I believe you're using a ruler yourself in the measurement lab because it's on your list. Yes, so you will be using a ruler. Just make sure that in chemistry we're measuring in centimeters, not in inches, and that you're paying attention to the lines and you're trying to be as accurate as possible. So for SigFigs, SigFigs are very important in chemistry, and we will use them throughout the semester and next semester if you're taking Chem 2. And then also they're going to appear in physics. So just make sure you pay attention to SigFigs. Some people care more than others. I'm one of those people that cares a lot because I've got that physics background. So it is important, okay? Also, just so you know, all conversion factors, which means they have an equal sign in between them, those are treated as exact values, which means they have infinite SigFigs. So we don't really count their SigFigs because they're infinite. Okay, and here's some example of these conversion factors. So we know that 1 inch is 2.54 centimeters. So we don't count it SigFigs because I could add a ton of zeros behind those numbers and it would be the same thing. Okay, also we know that there's 12 in a dozen. So anytime you see this equal sign between two numbers, just know we're not counting SigFigs on those, they're infinite. Okay, and here are the SigFig rules. There are a lot of them. I'll kind of try to go through examples as we go through them, but really SigFigs are a process and you just have to get used to it. There is a POGL on SigFigs that hopefully will help. Okay, POGLs are activities, that's what they're listed on your labs. So the first SigFig rule is that all non-zero values are significant. That just means if there is a number that's not zero listed, it counts, always. So all numbers that are not zero count. Rule 2, zeros between non-zero SigFigs or digits count. So I call this the sandwich rule. And that's because these zeros are sandwiched in between other numbers. So if they are included in the sandwich rule, they do count. Leading zeros. These are just placeholders always, and they are never significant. Never, not significant. Okay, it doesn't matter how many zeros you have. Until you get to the first non-zero number, they don't count. All right, and then the trailing zeros, these are a little different. Zeros that are trailing and have a decimal, they have a decimal, they are significant if they're after a non-zero number. If they have no decimal, they are not significant. So this is no decimal. And remember, trailing means they're at the end. Okay. So here are some examples you can look through. Just some things. So here we've got the sandwich rule, so all of them are. Here we've got the trailing. They are not significant because there's no decimal. Here we've got leading, so those don't count, but this last one does because there's a decimal and it's after a non-zero number. So this one has 4. Here, because of this equal sign, it's infinite or unlimited on this one. So scientific notation is a different rule, but everything in front of the times sign counts. So here we've got 4 in front of that multiplication sign, so we've got 4 SigFigs. And then same thing on this bottom one, it's in scientific notation, so all of them count. One other thing I want you to notice about all of these numbers is they show units. You will have to show units as we go through this class. And I know I'm not going to see your written homework, and tests won't be written either, but you need to make sure you're paying attention to units, because when we go back to a non-online format, teachers are going to start grading on, did you write your units? Are your SigFigs correct? Things like that that mastering chemistry may not be looking for. All right, so here we're talking about precision in glassware, and I know there's a picture kind of similar to this on your measurement lab. So here we have this meniscus, and that's just a curvature in the liquid. It's because of some intermolecular forces and properties that go with those, which are from Chem 2. But we're reading the bottom of that meniscus. Okay, from here, we will estimate the last digit always when we're measuring. So estimate last digit. So this shows to the 10ths place, we need to read it to the 100ths place because we're estimating the digit after. Even if it is directly on the line, you need to estimate that as a 0. So here it's saying, yes, it's between 4.5 and 4.6. I would say it may be 4.57. Now the book says 4.56, and that's okay that our estimated digit is a little off. Your estimated digit may not be the same as somebody else's estimated digit. These 2 digits are certain. This last one is our uncertain digit. Sorry, I know it's hard to see on that red background, but uncertain. Okay. Okay, we already talked about scientific notation. Just remember all the digits in front of the multiplication sign are significant. All right, so let's just do some practice. How many SigFigs are in each of these numbers? So here, no zeros. This is 3. Here, they're going to say this is infinite because you counted them. However, I'm going to go with 1 because there's only 1 digit there. Here, everything in front of the time sign. So this is 3 digits. D's a little more tricky. There are no leading zeros that count. So all of those zeros in front don't. This is only 2 SigFigs. This one, we've got that decimal, so everything counts. 5. And here we do not have a decimal. So we're only looking at 2 because those trailing zeros only count if there's a decimal. All right, then we've got multiplication and division rules, and addition and subtraction rules, and how they apply to SigFigs, because we're going to do a lot of math with numbers that have SigFigs. So for multiplication, you take the least precise of all of them, and that's what we use. Okay, so least precise, I'm going to put of total numbers. Okay, for addition and subtraction, it's still going to be the least precise, but it's going to be the smallest after the decimal. So I'm going to put smallest after decimal. Okay, we don't do addition and subtraction a ton in chemistry. We do a little bit, but really we're going to focus on that multiplication and division rule. So here are some examples. I've got 3 and I've got 1. So in my answer, I can only have 1 SigFig. We will be rounding, so just make sure you remember your rounding rules. We're keeping 1, we said. This is a 4, so we round, stay the same. Okay, let it rest. Remember, 4 or more Or sorry, 5 or more, raise the score. 4 or less, let it rest. Do not do anything from the end. We're only paying attention to the one right after the sig fig we're keeping. So here I've got 4 and 2. I'm keeping 2. Okay, they put 1.0 times 10 to the 1, or you can put 10 point. Because remember, if there's a trailing 0 with a decimal, it counts. All right, so here, this one is a little different. Notice these are conversion factors, and this is how we write them when we write them in this is called dimensional analysis. But remember, they have infinite sig figs. So when we start, we only give the sig figs from the given. So this one has 2. We're only keeping 2. The 7 rounds the 3 up to a 4. Okay. For addition and subtraction values, remember we're keeping the least after the decimal. And again, I'm so sorry. My dog is digging out all of her toys. Okay, luckily it's not the loudest toy, but my other dog sounds kind of like a bear when they're playing. So if you hear that in the background, that's what's happening. All right, so here we've got 2 after the decimal. Here we've got 3. We only keep the least, so we're looking at 2 after the decimal. But the 7 is going to raise us up to an 8 because rounding. And here we've got nothing after the decimal, super important. So we're going to get rid of everything after the decimal. You would still round if you needed to. But in this one, we don't. It's let it rest. Okay, so let's perform some of these calculations. You do follow orders of PEMDAS, so just make sure that. Okay, so for A, I've got 3 sig figs, 4 sig figs, 5 sig figs, and 5 sig figs. Remember, in multiplication, we're keeping the least. We go ahead and do our math. Okay, I do suggest you buy a TI calculator just because they're easier to function with. Okay, so I'm going to write some numbers. This is not the correct value. I was just writing some so we could see. So we already determined we're keeping 3. I'm going to underline the first 3. And that 7 is going to pull my number up. So my actual answer is going to be 7.79 because of sig figs. Okay, for B, remember we're looking after the decimal. I've got 3 after, 1 after, 4 after. So I'm only going to be able to keep 1 after the decimal, but we still do all the math. Okay, so for B in my calculator, I get 4.873. Again, we're keeping 1 after the decimal. So this comes out to 4.9 because of rounding. C is where things get a little complicated because now we have to use PEMDAS. Remember your PEMDAS rules, parentheses come first. So I am pulling from this section first, and I'm only keeping 2 after the decimal. Okay, so from this value, I've got 0.3455. I do want you to keep in mind we're only keeping 2 after the decimal. You do need to do the rest of the calculation with the whole number and then round at the end. So from here, I've got 4, way more than 4, 6, and now I'm keeping 2 from this one. So I've got 4.562 times 3.99870 divided by 0.3455, and my answer comes out to 52.799. Again, we're only keeping 2 total because from my subtraction, I was only able to keep 2. So C comes out to 53. For D, again, we pay attention to parentheses first, but we would have paid attention to multiplication before we did subtraction anyway. But I am going to go ahead and multiply those. And note, I'm only keeping 2 from there. So I've got 8.162 from that, and I'm going to subtract 8.02. But I'm only keeping 2 total from that, which is these first 2, which means for decimal, after the decimal rules, I'm only keeping 1 number after the decimal. Okay, so I get 0.142. So this rounds to 0.1 because of SigFig rules. So just make sure these are going to be the hardest ones. We're really only going to see this on that first quiz or the first test. There may be one on the final, but not too many. Okay, if you need more practice, please let me know. I got tons. Okay, this is where we're going to stop this video, and we will pick up here next time. Y'all have a good day.